Okay, hi everybody. My name is Avery, and I chose Homework 09 Problem 1. The reason I chose this is because I used to struggle finding the equation of tangent planes, but now I feel very comfortable with it. And I think it's because I did a fair amount of extra practice on it, and I think even though they're objectively easier problems, I think I just would get kind of confused and would make silly mistakes when it came to the partial derivatives, which I think is what tripped me up a lot. But anyway, I feel a lot more comfortable with them now, and I think that finding the equation of the tangent plane is a very foundational subject for what we've been learning lately. I feel like I find it come up in a lot of problems, so I definitely wanted to do some review for this for the exam. I thought that would be very, very helpful. So anyway, getting into the problem, I already have everything that I did written down. I'm just kind of going to walk you through it and explain what I did. So it says find the equation of the tangent plane to z equals f of xy equals e to the x plus y to the third plus 7. So the first thing I did really is I do this with every problem. I always just read the whole thing through and kind of come up with a plan for what I'm going to do. It's nice that this one walks you through it. First thing I did is I just kind of took notes on the problem a little bit. Like, for example, it says at the point 0, 3, 38. I noticed that one of the things that gets me confused easily is having the z coordinate in there if it's not really relevant to the problem, and in this case it's not. So I always just cross that out just so I don't get confused. And then I decided to find the partial derivatives. I knew that was the next step. So I started with f of x, xy, and I looked at the original function here, and I noticed that the only part that has the variable x in it is e to the x. So I thought about it and I was like, okay, well, what's the derivative of e to the x? It's just e to the x. So I wrote that down and then moved on to f of y xy, and I looked at it again and I was like, okay, what parts have y in it? And I noticed it was just the y and the y to the third. So I was like, okay, derivative of y is just 1, and then derivative of y to the third is going to be 3y squared. And then, so I got that part done, and then I went over here and I was like, okay, so now it wants me to just kind of fill in the relevant coordinates here to kind of have the formula laid out for me, which is going to be super helpful. So I just plugged those in, f of 0, 3 plus f of x, 0, 3 times x minus 0, which is the x coordinate, and then f of y, 0, 3 times y minus 3, which is the y coordinate we're given. And then I was looking at this and I was like, okay, I need to find f of 0, 3, f of x, 0, 3, and f of y, 0, 3. So I came back over here and I laid it out. I was like, okay, f of 0, 3, and I wrote it out. I plugged 0 in for x here for e to the x, and then I did plus 3 for y here, right, plus 3 to the third for y to the third, plus 7, and then I just kind of did quick little math in my head. 1 plus 3 plus 27 plus 7 equals 38, and then kind of did the same thing for the x partial derivative. Did f of x, 0, 3, e to the 0, what's that? It's always 1. And then f of y, 0, 3, came back up to f of y. I was like, okay, that's going to be 1 plus 3 times 3 squared. 3 times 3 squared is 27, plus 1, that's 28. So now that I have all my values laid out here, I like to have them laid out on the side. I, kind of followed this and decided to write it out with the actual values below. So I knew that f of 0, 3 equals 38 as I have laid out here, so I wrote that down. And then plus, it's going to be f of the partial derivative with respect to x, 0, 3 times x minus 0. So I was like, okay, what is the partial derivative with respect to x of 0, 3? have it laid out over here, that's 1, and then x minus 0 is just x, so it's going to be 1 times x. And I'm like, okay, I've got this part and this part knocked out, so now I'm about to attack the y portion of this equation, I guess. And I knew I needed to have the partial derivative with respect to y down here, so I looked over here and over to my all my information laid out over here, and I looked in, it's 28, so I wrote 28 down and then wrote y minus 3 down, and then I just wanted to simplify this. I know that you can technically put it in as that. If it can be simplified, I like it to be simplified. So then I just rewrote it as 38 plus x plus 28y minus 84, and just did even a little bit more simplifying. So it comes out to be x plus 28y minus 46, which tangent plane equation is just very helpful in a lot of problems I've found. Anyway, so then the next part of the problem, now use the tangent plane equation to approximate f at the nearby point negative 0.01, 3.03. So I looked back up at my tangent plane equation right here, and I knew that I had to plug this x coordinate, negative 0.01 in for x, and then the 3.03 in for y. So I just wrote that out down here. Negative 0.01 plus 28 times 3.03 minus 46, and just kind of solve that out here to get 38.83. And then I just wrote that final answer over here, just for clarity, really. But that's kind of all I got for y'all. How to find the equation of the tangent plane. I really like this problem because I feel like it kind of walks you through the steps, which is super helpful and is really helpful while learning. And again, I just think that this is a really good foundational topic that I would want to be very solid on for the exam. So that's all. Thank you so much for listening, and yeah, okay.